definition of an exponential function. Okay. If a is some number, okay, an actual bona fide number though. If that number is greater than 0, then what kind of number is it? What kinds of numbers are bigger than 0? Positive. Okay? So if a is a positive number and as long as a does not equal 1. 1's a positive number, it's going to be our 1 sort of eh. So as long as a is positive and a is not 1, then y equaling a to the x power, which we can also write as f of x equaling a to the x power. Is that fair? Either y equals or f of x equals? Okay. If we have this, then that equation there, we say is the exponential function base a. You remember when you have exponents, you have a base and an exponent? So that's all we're talking about. A is the base. A has to be some positive number. Okay? So with the calculator, I want to show you. Why not 1? What would 1 to the x power look like? It's kind of boring. It's actually just a constant function 1. Why? What happens then if I raise 1 to any power? I get 1, including 0, right? 1 to the 0th is 1, 1 to the first power is 1, 1 squared is 1, 1 to the third is 1, 1 to the fourth is 1, 1 to the pi is 1, right? Like if we do trace, pi, yeah, there it is, 1. To the negative 1, to the 0.5, it doesn't matter. These are not exponential functions, okay? So we say for any other positive number though, you're going to get a curve that looks like this, or you're going to get a curve that looks like this, one way or another. Okay? What about negative? Why can't it be negative?
The exponent?
The base. Parentheses, negative 2 raised to the x power. Check this out. Is there a graph there? If I do trace, well, there's a point. Right? But if I move there, no, those aren't points. Are there any other points? Tell you what, let me show you something. It's really cool. I'm going to change my window a little bit. I'm going to change it from negative 10 to 10 to negative 9.4 to positive 9.4. Come on, that's cool. Now when I trace, I get some points that show up, but you notice they keep hopping back and forth. Alright, so here's kind of what happens. When I've got a negative number, and I raise that to some like nice rational power, like I can do negative 2 to the first power. Negative 2 to the first power is negative 2, right? I can square negative 2. Negative 2 squared is positive 4, so on, right? Why does it keep jumping back and forth between positive and negative? What happens when I square a negative number?
It's positive.
It's positive, but what happens when I raise it to a third power, yeah? It's going to be negative, right? It's this idea. But what is negative 2 to the pi-th power? What happens if I try to take negative 2 and raise it to some pi or some other irrational number kind of power? What's that? Is that raising into an even power or an odd power? It's a mystery. And it's why we don't do negative bases. Okay? We don't have a good way of defining a negative number raised to some irrational power. That's strangely enough nothing that we've been able to well define. So we just leave it alone. We just, ignore it.